Find a possible solution for f of x, given that f of x is the integral of quantity e to the x plus e to the negative x squared. Okay, so this one looks, let's see, where are we going with this? So, rewrite it. So we have e to the x plus e to the negative x quantity squared dx. So our first thought is, so the general thought process is we'd want to do substitution. Actually, for that we want to do the power rule. Power rule is generally the easiest method of integration. So if we can do power rule, we want to do that one. Then we do substitution, and then we start grasping for straws. So for this one, I'm going to start by simplifying it because we can figure out what e to the x plus e to the negative x squared is. That's just foiling. And so first thing we're going to do is we're going to go for that. So this is e to the x plus e to the negative x times e to the x plus e to the negative x dx. And then expanding this out, we have e to the x plus 2e to the x e to the negative x plus e to the negative x e to the negative x dx. Okay? So then we can simplify this further, integral, by integral e to the 2x plus 2 plus e to the negative 2x dx. And to kind of convince you that this is sort of true, that this rule works, I'm going to do, let's say, 2 cubed. Can we do this? We'll do 2 to the first plus 2 to the first. No, 2 to the first times 2 to the second. That works. 2 to the first times 2 to the second. And if this is true, if our rule that we kind of did was true, then this should be 2 of 1 plus 2, which equals 2 to the third, which we know equals 8. 2 times 2 times 2 is 8. And so we look at this, this is 2, this is 4. 2 times 4 is 8. So it seems reasonable that when you multiply exponents like this, a number to an exponent has a number to the same exponent to an exponent, you can then add them together. So this would be e times e to the x plus x, which is e to the 2x. This is an exponential rule, and it is true, but it's one of those things where I'm always fuzzy on exponential rules and rules for logs as well. They're just not intuitive to me. And so one of the things I like to do is I like to pick an example. Usually using 2s and 3s and 8 is usually pretty easy. I just quickly pick an example, pull it out, and then see if it works. And it's it's not proof by any means, but it's kind of a reassurance that you're not completely wrong. So that's one of the things I kind of like to do every now and then. And it depends too how much time you have. If you're working on a very time-sensitive test and you don't have time to be careful, then you don't do it. But if you have a couple extra seconds, it's worth your time just to make sure you don't make a silly error that you can fix. Okay, back to the problem. So we have e to the 2x, which we can solve. So this will be e to the 2x over 2 plus 2x plus e to the negative 2x over negative 2. And you might be like, what? Where did that come from? Well, this is a combination. I'm going to do it just for this one real quick. This is e to the negative 2x dx. What we're going to do here is substitution. So we have u equals negative 2x, du equals negative 2 dx. And then solving for dx, we have negative 1/2 du equals dx. So we bring this down here. We say, all right, so we have e to the u du, and there's negative 1/2 in there. And so this becomes e to the negative 2x over, I'll say negative 2. And that's what we did over here. I've just done this enough times. I'm like, okay, I can see where this is going. And you probably are at the same spot too, where you can be like, okay, integral of e to the negative 2x, just e to the negative 2x divided by negative 2. If you can do that in your head, that's great. If not, don't push it. Feel free to, especially when you're practicing, go through the substitution and actually explicitly write this out. That'll help you kind of cement in your mind what to do for this situation. Okay, going back to the problem, and then there's going to be some sort of plus c. Yeah, that's not too bad at all. Now, originally, this problem looked pretty intimidating because you think that there's going to be something special about this e to the x plus e to the negative x squared. And there really isn't. You just FOIL it out and then look at each term individually because they're added together. Now, if they are multiplied together, you wouldn't be able to do that. But since they're added, you can. And you should take advantage of that. So, negative 2. Yep, negative. E to 2x, 2x to it. Here we go. And right there, that is the answer. All right, that's how you do a binomial expansion with exponentials. Not too bad, but it does take a little patience and a little bit of stepping back and looking at what you're doing. So thank you much. See you on the next problem.